Okay, we are going to talk about trig functions of any angle, and the first thing we want to talk about is that if I have an angle that I have an initial side, which is 1 ray, and then I have the measure of that angle, which a lot of times we call theta, almost all the time really in this class we'll call theta, and then we have our other side of our angle, which is our terminal side. We in geometry talked about angles either in triangles or other figures or just kind of out in space. And so in trig, we're going to actually put those into a standard position where right here on the positive x-axis we would have 0 degrees or 0 radians. And then if I have a positive angle, then my initial side starts here. No matter what, a positive angle goes counterclockwise, and then I draw the terminal side. If I have a negative angle, like if I said negative, 230 or something like that, I'm going the negative direction around, which is clockwise. And it may seem weird that the 0 degrees is right here, but if you remember when you learned about quadrants in Algebra 1, this is the first quadrant, because look, if I start at 0 and I am going counterclockwise around, this is the first quadrant I get to, this is the second quadrant I get to, this is the third quadrant I get to, and this is the fourth quadrant I get to. And so that's why we label the quadrants that way, and hopefully that'll make it easier to remember that 0 degrees starts over here with anything that we're talking about, like in trig, as in like we talked in 4.1 about a ship's bearings, where in navigation a lot of times they start with 0 up here and they go this direction, like a compass. Okay, so we may have some times where that comes up, but for the most part we're gonna put it in standard position, which means 0 degrees is right here on the positive x. Okay, coterminal angles. This is a term that basically means angles that are the same, that have the same terminal side, but that have, we say they have different measures. So let's think about this. If this is 0 degrees, well, this is 90 degrees because this is a right angle. This would be 180 degrees, which that's a straight angle, right? And so then 180 plus 90 is 270, and then 270 plus 90, because each of these intervals is 90, is 360. So we're basically saying that if I draw an angle here, like this, that angle could be either 0 or it could be 360 degrees. So any angle we have also follows that. And if I'm in degrees, what I would do is I would add or subtract 360 degrees, and that will tell me what some of the coterminal angles of my of the angle I have are. Now let's look at radians. Radians, I start off with 0 here. And this might be a little bit trickier. We could say, well, 90 degrees in radians, I times by pi over 180, and then I get pi over 2. So this is pi over 2 up here. Another way we can think about it is, I said a while ago in a different video, 180 degrees is the same as pi. There's a conversion thing going on there. So this is pi. And then 270, if I convert that, I get 270 if I convert, 3 pi over 2. Okay, so 3 pi over 2. So once I get all the way around, I end up with 2 pi, because if I'm thinking about a circle going around, what's the circumference of that circle? It's 2 pi. So that's why the 2 pi is there. So coterminal angles in radians, you would add or subtract 2 pi to get your answers. So if they give us something like 60 and they want us to find coterminal angles, the simplest way to do that is to take 60 degrees and add 360, take 60 and subtract 360. So I get 420 and -300. And so what we're saying is if I look at this angle that is 60 degrees, approximately here. Okay, this is 60 degrees, but I could also go all the way around my circle. I could go 360 degrees around and then 60 more, and that makes it 420. Okay, so that's the angle that I go all the way around and then I come back and stop here. That's 420. Or I could also say, well, what if I start at 0 and I go negative? I would go negative 300 degrees and get to that same line. Okay, so this is just a way of naming angles, basically other things. If I have something in radians and I want to add 2 pi, this is going to require some common denominator work. I need a 4 on the bottom, so that'd be 3 pi over 4 plus 8 pi over 4, which is 11 pi over 4. And then I would subtract by 8 pi over 4, which is negative 5 pi over 4. So that's the same thing, that those two angles will be in the exact same place as 3 pi over 4 if we draw them out. Evaluating trig functions given a point on the terminal side. So what this is saying is find the 6 trig functions given an acute angle in standard position whose terminal side contains the point 4, 7. Well, 4, 7 is somewhere around here, where I would go right 4 and up 7. So, I don't know, I just want a regular line. Okay, so I'm starting here with my angle. That did not give me a regular line, but that works. I'm starting here with this angle. I'm drawing a line through it. Oh, let me try this again so it looks straighter. Line. Okay, so I have a line basically coming out here because I've got an angle, okay, that's happening here, and it's causing there to be a point on this terminal side that is 4, 7. And what we can do is we can think of this like it's a right triangle. Okay, where this is theta, this angle, and then this bottom side of my triangle is 4 because I went to the right 4. This side is 7 because I went up 7 to get to this point. I went right 4 and up 7. So my sides are 4 and 7. To find the third side, I could do the Pythagorean theorem. 4 squared plus 7 squared is 16 plus 49, which is 65. And then I square root that. Square root of 65 does not simplify. So now I can write all of my trig functions. So sine of whatever this angle is opposite over hypotenuse. So 7 over square root of 65, which equals 7 square roots of 65 over 65. I have cosine, which is 4 over the square root of 65 equals 4 square roots of 65 over 65. And tangent, which is opposite over adjacent, so 7 over 4. Then I write the ones flipped. Cosecant. I'm going to flip the fraction before I rationalize it, which is why I wrote down what it was unrationalized, because if I flip this, that's a lot easier than flipping this and having to re-rationalize. So square root of 65 over 7. Secant is square root of 65 over 4. And cotangent is 4 over 7. So that's all of my trig functions. I just had to draw a triangle based on the fact that that point was 4, 7. Now let's think about how to apply this to any angle. Is that basically because we were able to draw a triangle here, like by connecting this to this, we drew a right triangle, and so that made this side that we have down here x. This side was y. And then this side over here we're going to call r because we're foreshadowing the whole unit circle thing. And it turns out that we can write our trig functions like this. Sine is y over r, cosine is x over r, tangent is y over x, and so on and so forth. So r equals, if I use the Pythagorean theorem, x squared plus y squared underneath the square root. So if I don't know what r is and I need to find it, that's what I would do, is the Pythagorean theorem. So let's use this for the terminal side that contains the point -3, 2. So I can draw this out and I can draw the triangle. -3 for x puts my triangle out here. -3, +2. Okay, or I can just think, hey, this is x, this is y. I can figure out pretty easily, hopefully, what r is. R is the square root of this. So that's 9 plus 4 is 13, so the square root of 13. Okay, which I'd have to do that even if I drew the picture. I'd have to work that out, that that's the square root of 13. Well, now I can just fill in what I have. Sine of theta is y over r. So that is 2 over the square root of 13, which is 2 square roots of 13 over 13. So cosine is x over r, which is -3 over the square root of 13, equals -3 square roots of 13 over 13. Tangent is y over x, which is 2 over -3, which is just -2/3. Cosecant is square root of 13 over 2. Secant is negative square root of 13 over 3. And tangent is cotangent of -3/2. Okay, so you can do the same thing by looking at the triangle and using opposite over hypotenuse and all of that stuff, and that's fine. Or if you can remember this, which the more you do it, the easier it will be to remember, and we'll talk about some different things that'll end up helping us to remember, I think. Then that's a good way of looking at it, where we wouldn't even necessarily have to have the triangle unless we just wanted to draw it. Okay. Now we are talking about evaluating trig functions using reference angles. And so it says, find the 6 trig functions of 240 degrees without using a calculator. So I want to figure out where 240 degrees is. So this is 0 degrees, 90, 180, 270. So 240 is somewhere in between 180 and 270. And it's actually, if we think about it, going to be 60 degrees past 180. Okay, so this is the triangle that we're talking about. And like I just said, this is 60 degrees, this angle in here, because to get over here, I went 180 and then I went 60 more to get to 240. So all the way around here from 0 is 240. What I care about is that this angle inside is 60 degrees, because now I can make this a 30, 60, 90 triangle, and that makes this the square root of 3, this 1, and this 2. But my y and my x are both negative here. So that'd be negative square root of 3 and -1. And now I can find the 6 trig functions using opposite over hypotenuse and all of that stuff, because I know that my reference angle is 60 degrees. I know that that's what's important, is that this angle inside of my triangle is 60 degrees. So that's square root of 3 over 2, but it's negative. Cosine is -1 over 2. Tangent is negative square root of 3 over -1, which is actually just positive square root of 3. Then cosecant is what we have flipped, so -2 over the square root of 3, which I rationalize and get -2 square roots of 3 over 3. Secant is -1/2 flipped, which is just -2. And cotangent is square root of 3 flipped, which is the same thing as square root of 3 over 1 flipped. So 1 over the square root of 3, which is square root of 3 over 3. Okay, so those are the 6 trig functions of 240 using our reference angle so that we can make a special right triangle. If we have some special angles now, that basically, what if we have an angle that is, right here. What if this is my angle? Okay, I'm starting, this is 0 degrees, so up here would be 90 or pi over 2, depending on how you look at it. Over here is 180 or pi, and down here is 270 or 3 pi over 2. Okay, and so I'm talking about at 90 degrees, what are my 6 trig functions? Well, let's think about a point that's right here. Let's say that this point is 0, 1. Why is it 0, 1? Well, we're foreshadowing the unit circle and basically saying, hey, it makes it really easy if we just pretend like we went up 1 unit. If this is 0, 1, what would r be? Well, we'd take the square root of 0 squared plus 1 squared, which is really just the square root of 1, which means r is 1. Now I can fill in my 6 trig functions from that chart. Sine is y over r, so that's 1 over 1, so 1. And so actually I'm doing sine of 90 degrees here, right? Not just theta, I know what the angle is. Cosine of 90 degrees is 0 over 1, because it's x over r, which is 0. Tangent of 90 degrees is y over x, which is 1 over 0, which I can't divide by 0, so that's undefined. Cosecant theta is 1 over 1 flipped, which is 1. Secant theta is 0 over 1 flipped, so that's 1 over 0, which is undefined. And cotangent theta is 1 over 0 flipped, which is 0 over 1, which is 0. Okay, so for these other quadrantal angles, we would think of this as the point -1, 0, because we went left 1 and didn't go up or down. This one we would say is 0, -1, and this one we would say is 1, 0. And pretty much if it's a quadrantal angle, then it's going to be, your answers are going to be like 1, 0, undefined, or -1 if you have something over here where we have negative values. I believe this is our last thing. Yes. Okay, so this is asking us to use one trig ratio to find the others. So if all they gave me was that sine theta is 3 over 7, and they didn't say anything else about it, there are 2 places where sine theta could equal 3 over 7, because our opposite side has to be positive 3. Our hypotenuse has to be 7. Well, doesn't that also happen over here, that our opposite side is 3 and that our hypotenuse is 7? Okay, so if they didn't give us this other part, that tangent is less than 0, then we would have 2 triangles, and so we would have way more work to do, really. But they told us 2 things here. And, there's actually an acronym that we can use to remember where the trig functions are positive. All of the trig functions are positive in the first quadrant. Sine is positive in the second. Cosine is positive. Nope, just kidding. That's wrong. Tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. And here's the acronym, or whatever you call it. All smarties take calculus. If you can remember that, all smarties take calculus, then you know that all sine, tangent, and cosine is where my positives are. So this is saying that sine, cosine, and tangent will all be positive in the first quadrant. Sine is the only one out of those 3 that's positive in the second quadrant. Tangent's the only one of those 3 that's positive in the third quadrant. And cosine is the only one of those 3 that's positive in the fourth quadrant. So this problem is telling me that tangent is negative because it's less than 0. And it's actually also telling me that sine is positive because it has positive 3 over 7. So if I look at this, sine being positive has to happen in the first or the second quadrant, so it can't be either of these. Tangent being negative means that it can't be the first quadrant because tangent is positive in the first quadrant. So the only possible place for it to be is in the third quadrant. So let's draw a triangle for 3 over 7. So my opposite side is 3, so it probably looks something kind of like this, where have 3 for my opposite side, 7 for my hypotenuse. I'm going to have to figure out what the third side is by doing 7 squared minus 3 squared, which is 49 minus 9, which is square root of 40, which is 2 square roots of 10 if I simplify it. And it's also negative because I'm going left on the x-axis. So I want to know cosine and tangent. Cosine of this would be adjacent over hypotenuse, which is negative 2 square roots of 10 over 7. I also want to know what tangent of it is, and tangent of this is opposite over adjacent, which is negative 3 over 2 square roots of 10. I'd rationalize that and get negative 3 square roots of 10 over 20. Okay, so this would be my 2 answers that I had. It didn't ask me for all 6, just asked me for 2 specific ones, so don't do more work than you actually have to. So that's going to wrap up 4.3. We'll talk about the unit circle in class, and maybe some other things in class, but this is the basic gist of what's going on in 4.3.